So with that motivation, let's first talk about what is called properties of region of convergence. Okay, so we talk about properties of region of convergence. So there are 12 properties. I think we will see one by one. Okay, so first one, what is the first property? ROC of x of s is a strip parallel to j omega axis. Okay, ROC of x of s is a strip parallel to j omega axis. So what do I mean by that? Let us take the previous example. So what is happening here? For the given signal x4 of t Laplace transform, we got that to be how much? 3 by s plus 2 times s plus 5. But what is happening to ROC? ROC is a strip, correct? So it is a strip from where to where? Minus 5 to minus 3. But is it parallel to j omega axis? Yes, so that fellow is parallel to j omega axis. Okay, and that is the case for in every example. Okay, so look at this one as the x3 of s, again that is 3 by s plus 2 times s plus 5. But what happened to ROC? ROC is real part of s less than minus 5. That is also a strip of infinite length, but that fellow is parallel to how much? Again j omega axis. Now let us look at the first example. Again Laplace transform is how much? 3 by s plus 2 times s plus 5. But what happened to ROC? ROC is real part of s greater than minus 2. So again, how is this looking? It is a strip again of infinite length, but that fellow is parallel to j omega axis. If you look at all the previous examples, whatever we have seen, you can easily notice that ROC of x of s is always parallel to j omega axis. It can be of infinite length or of finite length. Okay, right. Next, second property, ROC of x of s cannot contain any poles. Okay, ROC of x of s cannot contain any poles. That makes sense. Okay, they cannot contain any poles. Why? Because if it contains poles, what will happen at poles? What will happen to the Laplace transform? It will become infinite, means Laplace transform is diverging, but we want the region where Laplace transform converges. So definitely that region should not contain poles. If it contains poles, what will happen? Laplace transform will become infinite, means what? It will diverge. So that should not happen, and hence what is the requirement? We require Laplace transform or the region of convergence should not contain any poles. Okay, right. Next to property, third one. So what is the third property? Third property is ROC of x of s is a connected region. ROC of x of s is a connected region. Okay, that is important. Okay, it should not be disconnected. Is a connected region because we want common area, right? So what do I mean by that? So we will explain that with an example. If you look at the first yes, if you look at our, we'll take the last four examples, x1, x2, x3 and x4. Okay, so if you look at this one, so first example, which is e power minus 2t u of t minus e power minus 5t u of t. What is the Laplace transform we got? We got the Laplace transform to be equal to 3 by s plus 2 times s plus 5. So what happened? So two fellows will have different region of convergence. So second fellow we got ROC to be real part of s greater than minus 5. So first fellow we got ROC to be real part of s greater than minus 2. So when will both converge here? Both will converge in this region. Okay, so these two regions are connected. Okay, similarly if you look at the second example, which is crucial for us, what is that we have got? We have got x2 of t to be e power minus 2t u of t plus e power minus 5t u of minus t. So what is happening here? So first fellow has real part of s greater than minus 2. Second fellow has real part of s less than minus 5. We have two different regions. Are they connected? No, and hence what happened? The region of convergence, there is no common area, and hence what do we say? We say that the Laplace transform of x2 of t does not exist. Okay, so in that way, ROC should always be connected region. Okay, it should not be disconnected. So again, just for example, let us say we have a pole zero diagram in this form. Okay, so this is sigma j omega. Let's say I have a pole at +1, I have a pole at -1. Just for understanding, I have a pole at -3, let's assume. So let's say this kind of region of convergence is not possible. So this one and also this one. So this kind of region of convergence is not possible. Either that is possible or either the strip is possible. So less than -3 is possible, or between -1 and +1 is possible, but this kind of double shaded region is not possible. Okay, this is not possible. Okay, this is not okay, I will say that. Okay, this is not okay. So any one is okay, but both of them cannot be okay. Why? There is no common region of convergence. Okay, so that's what we mean by ROC of x of s is a connected region. Okay, right. So next, let's take the fourth property. So what is that? If x of t is finite duration, if x of t is finite duration, and if it is absolutely integrable, and if it is absolutely integrable, and if it is absolutely integrable, then ROC of x of s, then ROC of x of s is entire S plane. Okay, is entire S plane. Okay, except possibly excluding, you'll understand that. Okay, except possibly excluding s equal to plus or minus infinite. I will explain this with an example. Okay, but what is important? If x of t is of finite duration and absolutely integrable, then ROC is what? It is entire S plane. So ROC of x of s is entire S plane. Maybe we should include or exclude s equal to plus or minus infinite. Okay, so we will start with an example. Let us take delta of t. So what is the answer we got for this Laplace transform? We got Laplace transform to be 1. And what is ROC? It is entire S plane. Why? Whatever may be the value of s, Laplace transform is always 1. Okay. Yes. Next, let we took another example, which is delta of t minus 1. This fellow will have what as Laplace transform? It has e power minus s as a Laplace transform. And when will this fellow diverge? This fellow will diverge at s equal to minus infinite. So what is ROC? We can say that it is entire S plane. Okay, it is entire x plane, but what should we say? Except at s is equal to minus infinite. Okay, so that's what we mean by except possibly excluding s equal to plus or minus infinity. So depending upon the signal, we should exclude s equal to minus infinity or plus infinity. Okay, next let us take delta of t plus 1. What will happen to the Laplace transform of this signal? You get that to be e power s. And what is ROC here? ROC is again entire S plane. Correct? Entire X plane. But except, what should we exclude now? S equal to infinity. Except at s equal to infinite. Okay. Right. Now we will take combination of these three guys. So that is delta of t plus 1 plus delta of t plus delta of t minus 1. So what will happen to the Laplace transform? You get e power s plus 1 plus e power minus s. So what will happen to ROC here? ROC is again entire S plane. Okay. Now what should we exclude? We should exclude both x except s equal to plus or minus infinite. Okay, ROC the entire S plane except at s equal to plus or minus infinity. Why? If you substitute s with infinity, first fellow will become infinite, so second fellow becomes 0. Again, if you replace s with minus infinity, first fellow will become 0, but the third fellow will become infinite. Means what? Laplace transform diverges, and that should not happen. Why? We are talking about region of convergence, not divergence. So if you look at the signal, is it a finite duration signal? This signal is what? Delta of t minus, sorry, delta of t plus 1 plus delta of t plus delta of t minus 1 will look like this. Is it finite duration? Yes. Okay. And is it absolutely integrable? Yes. Why? If you take the integral of this, you have 3 Dirac delta functions. Each fellow has area of how much? 1. So if you integrate throughout, you get 1 plus 1 plus 1, which is equal to 3, which is a finite value. So if x of t is of finite duration, and if it is absolutely integrable, what will happen? Then ROC of x of s is entire S plane. Maybe we should exclude or include s equal to plus or minus infinite. Okay.